Hey guys, just a few more minutes to let people come, and then we're gonna start. We're actually approaching the end of our classes. I believe this week is the second last one. So next week, I believe next week is our last class. I'm not entirely. We're getting there. And actually, yeah, the Gauss contest itself is also coming up. So, yeah. We're almost getting to the end, so like I really hope this class has been great, and I hope you guys like learn stuff from it. I mean that's kind of the classes, so yeah, that would be an ideal thing. I'm gonna set up the screen share, and soon we can start. Am I glitching out? That would. Oh, okay. Yeah, I just got the notification for it. Okay. I hope you guys can see it. Again, just gonna wait a little bit more until it's actually 7 or 5 o'clock, depending on where you are. Then we're gonna start. Oh yeah, I actually would ask people to keep yourselves muted unless you're like asking a question or talking or something. Oh, okay, it's actually time. So we are going to start. Okay, I think this should be everyone. People usually show up at like 7-ish. Okay, so let's get into it. So in today's class, we're not talking about probability. We're talking about data management. Yeah, like mean, median, that kind of thing. Okay, every single math contest is a different set of questions. Well, the thing is, yeah, they have like different questions, but it's like generally the same stuff year to year. So I'd say the best thing to study for any math contest is to look at the archive of past contests, and then study from there. Because that same contest, but from before, you should probably go through those problems, like do them all yourself, like treat it like a real contest and do it like that. And then after that, look at the solutions and try to like learn the answers for all of the problems. So that's my advice for how to study. Oh, okay. I really hope this lag isn't too bad. Maybe if I turn this off, it'll be a bit better. Be able to find an archive of every single or almost every single math contests, and that archive will contain all of the questions from previous years. So my best advice is to go through those, do all of the problems in there, treat it like a real contest, and then after you do that, like read the solutions and learn how to solve all of the problems. That would be my best advice for doing any contest, because that's probably the most useful thing that you can use to study. All right, so yeah, it's great to see that more people are showing up. This is awesome. Anyway, let's look at the mean, or the average. I guess most people would call it the average, especially like in school right now. You might have learned this already, actually. I don't know when exactly you learned the mean and the average and stuff, but you might just cover. it could also include like the median or the mode, but usually when people say the average, they mean the mean. And the mean is basically the sum of all the numbers in a group divided by the number of numbers. So for example, in this set, we have 5, 6, 4, and 9, right? Like these four numbers, they have a mean or an average of 6. Because we add up 5, 6, 4, and 9, we get the sum of that, and it's 24. And now since there's four numbers, we divide 24 by 4 and we get 6. So the mean of these four numbers is going to be 6 because it's those added up divided by the number of numbers. Let's do that. Just private message it to me when you have it. This should be really quick. What is the mean of 4 and 7? Oh, yeah, if you forgot to mute, that's fine. But oh, okay, yeah. Well, these are coming in fast. Just gonna message that to everyone. Okay, these messages are coming in way too fast for me to answer them. I'll answer as many as I can, but I'll just let the answers keep coming in until everyone has them. Yeah, I like the participation though. Like whenever I get so many answers that I can't respond to all of them, that's actually a good thing. And I like it when that happens because that means everybody is responding really well. All right, yeah. It's 11 over 2 or 5.5, depending on how like you did it. Because 4 plus 7 is 11, and you divide it by 2, 5.5. Average of Am I liking it really bad? That would not be ideal. I wonder why that could be. Yeah, I'm just gonna let the answers continue to come in because I literally cannot answer all. Super great. It's unmuted. I hear sounds. It's fine.
So what do you mean by the numbers 8, 9, and 19?
Yeah, so what's the mean of them? Find like the average of these three.
Wait, is it the mean and average?
Yeah, the average.
Yeah, then it's like
So
8
the
plus.
average of the three numbers,
Oh, okay.
8 plus 9 plus 19 is 8 plus 9 plus 19 is 36. And since you're dividing it by the number of numbers, and there's three numbers, 36 divided by 3 is 12. Last one. This one is like a bit longer, but a negative 5, 6, 9, 26, and 69. Nice. But yeah. Hopefully I'm getting everyone. Honestly, like I personally think involving the mean are a bit annoying because the mean is like pretty easy to calculate. It just takes forever. Couple minutes. Okay. Yeah. You guys got this one pretty quickly. It's 21 because all of these and the mean of well, the mean would just be 105 divided by the number of numbers, which is 5. So that's 21. Good job. A lot of you guys got this one too. Okay, now the median. This one's a lot easier. The median, or the middle value, is a set of terms when you list them out in increasing order. So when there's an odd number of terms, you just take the number in the middle when you list them out in terms, you take the average of the two values in the middle, or the mean. Yeah. So find the median of these. This should be really fast. Like you doesn't immediately know. I need more of you guys to answer this. Like you should immediately know the answer to this one as soon as you look at this. So what is the value of the number in the middle when you list them out in increasing order? All right. So I think that was enough time for everybody to answer. Yeah, it's six. They're already listed out in increasing order, and six is the one in the middle. Um, yeah, fairly obvious. So they're already in increasing middle six.
I think you're lagging like really bad. You're literally
I'm really
frozen.
sorry about this. I don't know how to make it lag less. Maybe if I close some tabs. Um,
Oh my god, the screen's
I
lag.
actually, most of my tabs closed.
I think you should like try leave
um
and rejoin. That's usually what works for me.
okay. If I leave though, that'll end the meeting for everyone because I'm the host.
Oh,
So that would be really inconvenient.
yeah.
I I'm on my normal Wi-Fi. I really don't know what could be causing this. Oh, weird. Anyway, so what's the mean or sorry, what's the median of these five? Again, median is pretty simple, so like it should be easy. Okay, yeah. You guys all got this. It's nine. Because the numbers in increasing order are like that. Nine is in the middle, so it's nine. Now, what about these six? What is the median of these six numbers? Uh, okay, yeah, now some people are struggling. Okay, yeah, let's just go into the solution. It's
Isn't the
four.
answer four?
Um, yeah, the numbers in increasing order are negative 18, negative 2, 2, 6, 17, and 24. 2 and 6 are the ones in the middle, so the average of 2 and 6 is 4. You guys got that? Because like when you have an even number, there's no really in the middle. So we have to like take these two that are in the middle because like these two are both kind of in the middle. They're since it's like an even one. So we just take the average of these two numbers when the median is like that. All right. Cool, cool, cool. Let's move on. Now the mode. This one's really easy. Really fast. So the mode of a set of numbers is that number that appears the most often in a set of numbers. So like for example, in this long line of numbers, the mode is two because two appears the most often. 2 appears 4 times when all the other ones appear less than 4 times. But if there's lots of numbers that appear the most often, then all of the numbers that appear the most often are the mode. So here in this big line of numbers, both 3 and 5 are the modes because they both appear the most often. They appear 3 times, so they're both the mode, 3 and 5. We don't do anything weird with like taking averages here or anything. If there's multiple numbers that appear the most often, they're all the mode. Okay, now the range. These are just definitions right now, honestly. The range, it's just the difference between the largest and the smallest number in the set. So for example, in this big set, the highest number is 8, the lowest number is -3, it's like 8, -3. So the range is just 8 minus -3, which is 11. Okay. Now, how do we do problems involving the mean? So usually it's more useful to convert like the mean to a sum because um, it's usually more useful to convert the mean to a sum, like, especially when you're doing problems involving what the mean becomes if you add or subtract a term. So like if we were doing a problem where it's like the mean is like some number, and when we add another element to the set, which is like a different number, what does the mean become? It's usually more useful to just convert the mean to a sum. And you can do that. If you know how many numbers are in the set, what the mean is. So for example, the mean of 3 numbers is 6. What's the new mean when I add 10 as the 4th number? So if the mean of 3 numbers is 6, then the sum is 3 times 6. So the mean times the number of numbers, and that's 18. 18 plus 10, which is the new, so this is the sum after I add the 4th number, it's 28. So the new sum after adding 10 is 28. And then the mean of the 4 numbers then is the sum, which is 28, divided by the number of numbers, which is 4. So that's 7. So the new mean is going to be 7. You guys got that? Hopefully, because now we're going to do a problem. So the mean or the average of a set of 6 numbers is 10. When the number 25 is set, so one of the numbers in the set is 25, but now it's been removed. So what's the new mean? Well, you guys are doing this, or at least the first few of you are. Guys, just a reminder, if your answer isn't one of the options, that means you got the wrong answer. I just like to point that out because that's going to be immensely useful on tests. So I haven't responded to you yet. I'm having a massive influx of people I need to reply to. what is that symbol? Oh, okay, that makes more sense. Someone sent me that thing. Okay, yeah, I think that's most of the answers now. Let's solve this problem. It's really fast. So the average of the six numbers is 10. So the sum of the six numbers is 60, right? Because you just multiply the number of numbers by the average or the mean to get the sum. So when 25 is removed, now the sum of the remaining five numbers is 35. So you divide that by the number of numbers you have, which is 5. So that's 7. So the new mean is going to be 7. Another problem. Rishi got the following marks on 4 math tests: 71, 77, 80, and 80. But he writes one more math test, and he can get like a number between 0 and 100 inclusive as one of the results on his test. So which one of the following is a possible average for his 5 math tests? that logic. I'm not actually saying stuff. Okay, so someone said A, B, C, D, or E, and well, I guess you're technically right. That was kind of funny, but please do try to solve the problem too. The four scores that he got is 71 plus 77 plus 80 plus 87 plus yeah, which is 315. So now we calculate what the corresponding sum would be for each possible average by multiplying by 5. Because like if we go back a bit, like these are the possible averages. So if it was the average, then the sum would be multiplied by 5, since it's the average of 5 things. So the possible averages for each of the options are 440, 310, 410, and 420. Now remember, this is his sum for the first 4. And these options that we have here are the sums for the 5 after he takes his last test. So his last test can only add a minimum of 0 and a maximum of 100 to his sum. So that means that each of these numbers has to be obtainable by adding adding a number less than 100 and greater than 0 to this number. So let's just go through these and look at it. So 440, you have to add 125 to 315 to get 140. He can't get 125 as a possible score because he can only get up to 100. So he cannot get another one that adds up to 440. That just doesn't work. Now 62 times 5, which is 310. This is less than 315. So no score that he can get can be added to 315 and get to 310. That just doesn't work. 410. So this is adding 95 to his score, or to his total. So this is possible because 95 is between 0 and 100. So he could get 95, and if he got 95, it would take his average, or it would take the total from 315 to 410, which then would give him an average of 82. For 84, this is also not possible. You're adding 105 to get from 315 to 420. Nice. But yeah, it doesn't work. 86, 430, also like the same deal. You're adding 115 to 315 to get to 430. Still not going to happen. It doesn't work that way. So out of these possibilities, only 410 is 315 plus a number between 0 and 100. So that means that only 82 is a possible average. Oh. So someone said that they have a different solution. And actually, that's a pretty cool solution. So let's see. They said that what they did was they found the average if he got 0, and then the average if he got 100, because those are the two extremes. So any average has to be between those two. So yeah, like let's actually look at this solution that somebody just sent me, because that's also a good one. So if he got a 0 on his last test, the average of the 5 would be 63, since that's 315 divided by 5. Now, if he got 100 on his last test, then his average would be 83, because 83 is 415 divided by 5, and that would be his sum if he got 100 on his last test. So between those two, between these numbers, between like the two values, 63 and 83, only 82 is one of the options, like between those two values. So yeah, you can only get 82. That's a smart solution. Okay, anyway, let's move on into the next problem. Actually, no, it's more content now. So sets and set theory. So just the basics, but this is what you need to know for the Gauss level. So sets are objects that are groups that objects can be placed into. And some examples of sets include the numbers that are divisible by 4, or the students in a school that are in grade 7, or like candies that are green, right? These are all sets of things because yeah, they're just groups, I guess. And sometimes Gauss problems will require you to use, or they'll be simplified by using sets. So for example, how many numbers between 1 and 100 inclusive are divisible by 2 or 3? Well, there's 50 numbers that are divisible by 2, and there's 33 numbers that are divisible by 3. But is that the end? We just add these together? No, you can't, because some of the numbers are divisible by both 2 and 3, and you're counting them twice like that. But the question isn't asking count twice. So this would 3 right now, but the answer is not 83. So it can be helpful to think of it like this. So look at this Venn diagram. So one of these circles is the numbers that are divisible by 2. And the other one is the numbers that are divisible by 3. So over here, we have the numbers divisible by 2, but not by 6. Here we have the numbers divisible by 3, but not by 6. And here in between, we have numbers divisible by 6, since 2 times 3 is 6. So right now, when we found the numbers that are divisible by 2, we took everything in this hoop. So if I can annotate real quick, we took like everything in this hoop, and including this is where we got our 50 from, the numbers that are divisible by 2. And we got our 33. It was these ones. So every number, including the ones in between, but is in here twice. Once when we were counting the ones divisible by 2, and once when we were doing the ones divisible by 3. So we counted those numbers twice. And that's a problem because now it means this isn't like the real answer and the real numbers we're looking for. So does anyone know what to do then? Because if that's not the real answer, what should we do? Which is what the real answer. Any ideas? What can we do here to solve the problem of us counting some numbers twice?
Divide 100 by 6 and take the whole number out of it and use that as the answer.
Just the number of numbers divisible by 6. That's not quite what we're looking for. For the and 3, we're looking at the numbers divisible by 2 or 3. So that's not quite what we're looking for. Now what is the numbers that are divisible by both, and you want to put that down as our answer. But that's just the numbers in here, like in this middle part. That's part of it, but what about the ones outside that middle part? You also have to count these ones. So what are we going to do? Well, any ideas? No? Okay. Well, I'll tell you what we're going to do. So we're going to count all of the numbers in the circle, and then count all of the numbers in the second circle, and to subtract the ones in between, because we count these ones, and then we count these ones and these second time. So now when we subtract the numbers divisible by 6, that'll be every single number in here counted exactly once. So, oops, we went too far. Okay. So we take the set of numbers that are that are divisible by 6. So that means we have to subtract 16 from our sum so that we're not counting the middle numbers twice. So we do 50 plus 33 minus 16, that's 67. So the answer is 67. Now, how many numbers between 1 and 120 are divisible by 2, 3, or 5? So now you have 3 possible numbers. And I'll just give you this tip: draw the Venn diagram, figure out what you need to like add and subtract and stuff. The same way as we did before. This problem is actually really quick if you just know what to do. And you might see like this exact problem or something very similar on Gauss. So 3. I don't think it would be 3. Now, the reason I don't think it's 3 is like, let's just take the first ones, 2, 3, and 5. Like, that's already 3. Now there's another one, 4. 4 is also divisible by 2. That's already more than 3, so it can't be 3. Remember, we're not talking about how many circles the Venn diagram has. We're talking about like how many numbers there actually are. I don't quite follow. Okay, so it should be a number you're getting, and it should be, okay, so we're getting where? Okay, so what you want to do, I'm just going to give a hint because nobody's got it, which is a bit unfortunate. So
Have you looked at
first,
mine?
how many numbers are divisible by 2? There's 60, right? There's 60 numbers divisible by 2 that are equal to or lesser than 120. How many numbers are divisible by 3? There's 40, right? How many are divisible by 5? There's 24. So now we add these together, right? That's going to be 124. But we're not done yet because we counted a lot of numbers twice. So we counted the numbers that are divisible by 2 and by 3 and 5. So like, what do we do now? Okay, so this problem must be a bit hard. And yeah, I know why. It's like if you don't know the exact way to solve this problem, it's really hard to it's a bit hard to like figure this out. Okay, so I don't think I should just make you guys keep guessing. Let's just go into the solution. So the number of numbers that are divisible by 2 less than 120 is 60. Then divisible by 3 is 40, and divisible by 5 is 24. So like right now we have a sum of 124. But now the number of numbers that are divisible by 2 and 3, 3 and 5, and 2 and 5 are all being counted twice. So we subtract the numbers that are divisible by 2 and 3, which is 6, 3 and 5, which is 15, and 2 and 10, which is 2 and 5, which is 10. Right? We have to subtract all of the numbers that are counted twice. So there's 20 that are divisible by 6, 8 that are divisible by 15, and 12 that are divisible by 10. So now we subtract these, and we're at 84, which is the answer, right? But it's not. Now the reason is the numbers that are divisible by 2, 3, and 5, so the numbers that are in all three of the categories are now being counted 3 times and then subtracted 3 times because we counted them under numbers that are divisible by 2, numbers that are divisible by 3, and numbers that are divisible by 5. So we counted them 3 times, but now we subtracted them for numbers that are divisible by 2 and 3, 3 and 5, and 2 and 5. So now we're not counting the numbers divisible by 2, 3, and 5 at all. We're counting them 0 times. But we have to count them 1 time because we have to count all of the numbers. So that means that we now have to add these again. 2 times 3 times 5 is 30. And there's 4 numbers that are divisible by 30 that are less than 120. So the number of numbers is therefore 60 plus 40 plus 24 minus 20 minus 8 minus 12 plus 4. Because the first 3 are divisible by 2, divisible by 3, and divisible by 5. That's divisible by the 3, divisible by all 3. So it's 88. Yeah, do you guys start to understand now? Anything unclear about the solution? Okay, so since no, back to the Venn diagram thing, when you're using set, information will usually be in one of these categories. It's saying in leggy, so I'm gonna wait. Okay. Yeah, so the useful ones you want are the ones that are in A but not in B but not in A and B, and in neither A nor B. So you want to figure out these 4, the values of these 4. But when you're given some of these like random ones, so like if you know how many are in B, and you also know how many are in A and B, then you can take the number that are in A and B and subtract the number that are in B to get the ones that are in A but not in B. If that makes sense. There's like some like kind of logic, brain gymnastics stuff going on here. But usually you can use some of these sets to figure out like some of the other parts of the set. So this is kind of like as deep as set theory goes for the Gauss level. Just know how to use these to figure out other ones. Do you guys think you can do that, or are you completely lost about what all these words mean? if you understand, let's go into a problem. So there's 50 students participation in hockey and baseball, so total of 50. The results of the survey were 33 students play hockey, 24 play baseball, and 8 play neither. So how many students surveyed play hockey and baseball? No, no, don't want to give you guys the solution. Yeah, so oh wow, that was a fast solution. Okay. Um, yeah, right. Someone's saying that for a question 22, this is pretty easy. It is because this is one of the formula based ones. Formula, and you already have the answer because you really just need to use strategy. Uh, don't know the formula or they don't know the strategy. So once you know the strategy, of course, it's going to seem easy to you. Okay, let's go into why is it on question number 20? Okay, so two. So it's not easy for them. But like second, this is older. So it's from like 16 years ago. And that's why it's a bit easier. It's because they've been getting harder over time. So you wouldn't see this on question 22 in like 2021. It 20 years, but it still would be pretty who play neither hockey nor baseball. So that means that there are 42 students who play hockey or baseball, right? Because if there's 8 who don't play either, then there's 42 who play one of the two. Um, and out of the 42 who play hockey or baseball, the car, I don't hear anything. That would make that sound. Oh, the car. Those are like actual cars outside my house, so I don't think I have the power to mute them. Anyway. Yeah, so out of the 42 who play hockey or baseball, there's 33 who play hockey. Like we're given that there's 33 who play hockey, so that means that there are 9 people who play baseball but not hockey. Because these 42 people are people who play one or both of the sports. So if 33 play hockey, there's 9 who play baseball but not hockey. So that means out of the 24 students who play baseball, there are 9 who don't play hockey. So that means the rest of them play baseball and hockey. So 24 minus 9 is 15. So there are 15 students who play hockey and baseball. You guys got that? Well, this is for today. No questions? Okay. So if there's no questions about anything, well, that's the end of class. So, uh,
Thank you. Goodbye.
Okay.
See you next time.
Yeah,
Thank
so
you.
Bye.
okay, yeah, I hope you guys learned something. Have a nice week. I'll see you guys next week.